Hello dear friends, welcome to my channels. Today's discussion is calculus. So friends, calculus means in here my topic is ODE, PDE and integral equation. So friends, let's start to discuss. Let U be the unique solution of del square U del t square, del square U del x square, and x belongs to R, where f such that R tends to R satisfies the relation fx is equal to x into 1 minus x for all x belongs to 0, 1 and fx plus 1 equals to fx for all x belongs to. So then you have 5 by 4. I have to find out. So how we can find out solution? Our solution is that u x comma t equals to half f x plus t plus f x minus t. U half into 5 by, sorry, not into, comma 5 by 4 equals to, so friends, actually the formula is, okay, formula I will write, what is the formula? D'Alembert formula I will write. Now at first I will solve this problem. Half into half 1 by 4, 1 by 2 plus 5 by 4 plus f into a 5 by 4 minus 5 by 4 half minus 5 by 4. So it can be written this way: half into f into 7 by 4, 1 by 2 plus 5 by 4 plus f minus 3 by 4. This is the formula. You can see that f minus 3 by 4 equals to f minus 3 by 4 plus 1, because friends it is given that fx plus 1 equals to fx. So if I use this, apply this formula, so f minus 3 by 4 equals to f 1 by 4. So I can write in here half into f 3 by 4 plus f 1 by 4. So this problem I can write half 3 by 4 means 3 by 16 plus 3 by 16 equals to 3 by 16. So friends, this is my answer, but I will discuss the formula of D'Alembert equation, differential equations, because this is the wave equation. This equation is called wave equation. So for wave equation, we have to remember that del square u divided by del t square is equal to c square into del square u divided by del x square. Then for homogeneous equation is homogeneous equation for homogeneous equation half into ux comma t equals to half into f x plus t plus f x minus t plus 1 by 2, sorry, it is c x minus x plus ct, so 1 by 2 c x minus ct into x plus ct. G I into d I. This is the formula. Gi is equal to, this is equal to Gi equals to del f del u, sorry, del u by del t, and this is fx plus t equals to u x comma 0. This is my homogeneous equations form. But non-homogeneous equation, there is another equation. This is the non-homogeneous. I discussed it in my video. So the admissible extremal for jy log z e to the power minus x y dash whole square to e to the power x y dash plus y, where y log z equals to this 1 and y0 is free. So 4 minus e to the power minus x to 10 minus 10 and e to the power 2x minus 8. I have to find out this formula. If x comma y dash e to the power minus x y dash whole square plus 2 into e to the power x y dash plus y. So del f by del y minus ddx of del f by del y dash equals to 2 into e to the power x minus equals to 0. That implies 2 into e to the power x minus ddx into 2 y dash e to the power minus x plus 2 e to the power x equals to 0. So e to the power x minus of minus y dash e to the power minus x plus y double dash e to the power x plus e to the power x equals to 0. Next is that e to the power minus x y dash minus y double dash equals to 0. That implies y dash minus y double dash equals to 0. So this d square minus d equals to 0. That implies d equals to 0 and d equals to 1. So yx is equal to c1x plus c2 e to the power x. Now y log z equals to 1. If this is given, you will see y log z equals to 1. So 1 is equal to c1 plus c2 e to the power log z. That implies 1 equals to c1 plus 3c2 and y0 equals k, and k equals to, that implies k equals to your c1 plus c2. This is the number 1 and this is number 2. 1 minus k equals to 2c2. So c2 equals to 1 minus k divided by 2, and c1 equals to 3k minus 1 divided by 2. So y equals to 3k minus 1 divided by 2 plus 1 minus k divided by 2 e to the power x or x equals to 3k minus 1 divided by 2 plus 1 minus k divided by 2 e to the power x. So take k equals to 3, then we can get easily this form. So this answer is correct, 4 minus e to the power x, but this answer is also correct, e to the power x minus 2. And when friends k equals to minus 3, k equals to minus 2, when k equals to minus 1, when k equals to minus 1, then it is minus minus plus 1 and c2 equal to 1 and c1 equals to minus 2. So this option is also correct, but this is cannot be possible. This is cannot be possible and this is cannot be possible. So my given answer is option A and option B. So dx, this equation is Lagrange's equation, friends. Lagrange's equation. So dx divided by x square is equal to dy divided by y square is equal to dz by x plus y into z. So dx, integration dx divided by x square is equal to dy or integration after that 8 minus 1 by x equals to minus 1 by y plus c1. I can write c1 equals to 1 by x minus 1 by y. So 1 dx minus 1 dy plus 0 dz divided by x squared minus y squared plus 0 into x plus y into z into 0 equals to dz divided by x plus y into z. So I get the value is dx minus y divided by x minus x plus y into x minus y equals to dz divided by x plus y into z. So this is cut. So now integrating both sides. So d of x minus y divided by x minus y integration is equal to dz by z equals to log. So friends, I get the value log z into plus log c. So x minus y divided by z equals to c2. So this is my answer. Now again what we find out. Now I have to find out c3. Y dx plus x dy plus 0 dz divided by y x squared plus x y squared equals to dz divided by x plus y into z. So it can be written dx comma y divided by xy is equal to dz divided by z. That implies log xy log z plus log c3. So I get the value xy is equal to z c3. So c3 is equal to xy divided by z. So this is my way c1 c2 c3. Now we know that if cj equals to fci equals to cj, and if cj equals to ci, so if ci comma cj equals to 0, So where f is a arbitrary differentiable function, where f is arbitrarily differentiable function, differentiable function. So you see that it is, so you can write this way that FCI FCJ equals to 0. Just putting the value. Yes, problem is from directional derivative. U x comma y comma z equals to x square minus 2y plus 4 z square f, and v equals to 3 by 5 I minus 4 by 5 k and p equals to 5 1 comma 0. So du equals to del u by del x and del u by del y and del u by del z. This way I can write, and after that write this way 2x minus 2 into 8z3 by 5 0 and minus 4 by 5. So my answer is 6x by 5 plus minus 32 z divided by 5. So the point is 5 comma 1 comma 0. So this point it can be written as is 6 because it is 6 and it is 1. 0, so it is 0, so the point is 6. Next problem is integral equation. So ux, both side, lux is equal to lx, and apply at first I write by convolutions. It can be written that ux is equal to x plus 2 into cos x star ux. So lx plus 2 into l cos x into l ux 1 by s square plus 2 into s divided by s square plus 1 into u bar x equals to u bar x. So 1 minus 2s divided by s square plus 1 into u bar x is equal to 1 plus s square plus 2s divided by s square plus 1. So friends, we need to see the formula. What is the formula? I have already written the Laplace formula. So L1 by x, L1 equals to 1 by s, L inverse 1 by s equal to 1, and Lt to the power n equals to n factorial divided by s to the power n plus 1, gamma n plus 1, L inverse s to the power n is equal to t to the power n minus 1 divided by n minus 1 factorial. L e to the power at is equal to 1 by s minus a. L inverse 1 by s minus a is equal to e to the power at. L sin at is equal to a divided by s square plus s square. L inverse s square plus s square is equal to sin at divided by a. L cos at is equal to s divided by s square plus s square. L inverse cos s divided by s square plus s square. L sin h at is equal to a divided by s square minus s square. L inverse s square minus s square is equal to L cos h at is equal to s divided by s square minus s square. L inverse cos L inverse s divided by s square plus s square. L e to the power at t to the power n is equal to n factorial into s minus a whole to the power n plus 1. L inverse s minus a whole to the power n plus 1 is equal to e to the power at t to the power n factorial. L divided by s minus a whole square plus b square. L inverse s minus a whole square plus b square is equal to 1 by b e to the power bt sin bt. L e to the power at cos bt is equal to s minus a whole square plus b square. L inverse s minus a whole square plus b square e to the power at cos bt. This formula must remember. When sin L sin at, must remember, hence L sin at is equal to a divided by s square plus a square. But when L e to the power bt sin at, then it is a divided by s minus b whole square plus a square. This kind of problem. Okay, so L e to the power at cos h bt is equal to s minus a whole square divided by b square. L cos at equals to s divided by s square plus a square. So friends, in our given problem, we see cos x minus t. That's why is divided by s square plus a square. We just directly Laplace transformation used Laplace transformations. Now L if n f bar s to the power n minus 1, f0 s to the power n minus 2, f dash 0 s to the power n minus 3, f double dash 0, and fn minus 1 0. This is very important formula, friends. And L ft by t is equal to s2 tends to s to infinity fs ds. L into t to the power n ft dt is equal to minus 1 to the power n dn s to the power n f bar s. And L0 by t fsds is equal to 1 by s f bar s. Must remember, friends, this formula is very important. 0 to t fsds 1 by s fs. Another is L ft by t is equal to s tends to infinity fsds. And t to the power n ft dt is equal to minus 1 to the power n dn ds whole to the power n f bar s. L inverse s into f bar s is equal to dt of ft L inverse s to the power n f bar s derivative in a derivative of ft. L inverse f bar f by s is equal to 0 to dt, And another vector A inverse f is gs is equal to 0 to 2 f u g t minus u f plus g. This theorem is called convolutions theorem. So friends, let's go to solve that problem or given problem. So friends, that this is my problem. Now u bar x, u bar s I can write equals to, it is u bar s, u bar s, u bar s equals to s minus 1 whole square divided by s square plus 1 divided by 1 by s square. That implies equals to s square plus 1 into s minus 1 whole square. And equals to 1 by s square plus 2 by s minus 2 divided by s minus 1 plus 2 divided by s. So u bar, so taking inverse Laplace transformation, we have ux is equal to L inverse 1 by s square plus L inverse 2 by s minus L inverse 2 by s minus 1 plus L inverse 2 divided by s plus 1 whole square. So L inverse x s square is equal to x plus 2 minus 2 into e to the power x plus 2x into e to the power x by the formula. I have already discussed this formula. Where this formula is, again I have written that L inverse 1 by s equals to 1, L inverse 1 by x to the power n plus 1 equals to e to the power n divided by n factorial. This is the given formula. And L inverse 1 by s minus a whole to the power n plus 1 equals to e to the power at into t to the power n divided by n factorial. This formula I apply in here. So I hope I can clear this formula, friends. Now I will go to solve, find the resolvent kernel of the Volterra integral equation. Ax, t equals to 1. Here k x, t equals to 1 So k1 x comma t equals to k x comma t equals to 1, and k2 x comma t equals to t2x equals to k1 x comma z and k z comma t d z. All the function is constant, so t into x into dz equals to x minus t. Now again we discuss that similarly k3 equals to t x into k x comma z k k2 z comma t dz. So the value is t comma x k x minus x comma z equals to 1 and k2 z comma t equals to z minus t into dz. So this value will become x minus t whole square divided by 2 factorial. Again k4 x comma t equals to t2x k x comma z into k 3 z comma t dz equals to 1 by 2 factorial tx into z minus t whole square into dz equals to 1 by 3 factorial z minus x minus t whole cube. Similarly, kn x comma t equals to 1 by n minus 1 factorial into x minus t whole to the power n minus 1. So friends, I get the value. Now resultant kernel are x comma t comma lambda equals to 1 plus lambda x comma t x minus t divided by 1 factorial lambda square x minus t whole square divided by 2 factorial plus lambda x minus t whole cube divided by 3 factorial up to infinity, that equals to e to the power lambda x minus t. Next, so kx comma t equals to e to the power x minus t and equals to k1 x comma t. That's why another is k2 x comma t equals to t2x k x comma z into k1 z comma t dz. So it can be written this way: t into x and e to the power x minus z into e to the power z minus t into dz. After that, friends, we can write this way: e to the power x minus t into t2x dz equals to e to the power x minus t into x minus t. In k3 x comma t equals to x k x comma z into k2 z comma. So the t2x e to the power e to the power x minus z into e to the power z minus t into z minus t dt. So z minus t dt. So e to the power x minus t into x minus t whole square divided by 2 factorial. After that, I can write k m x comma t k n x comma t equal to e to the power x minus t into x minus t whole to the power n minus 1 divided by n minus 1 factorial. As R resultant kernel x comma t comma lambda equals to m equals to 1 to infinity lambda to the power m minus 1 km x comma t. So I am just putting this formula in here: x minus t plus lambda e to the power x minus t into x minus t divided by 1 factorial plus lambda e to the power x minus t lambda x minus t lambda whole square divided by 2 factorial up to infinity. So we get the value is equals to e to the power x minus t into e to the power lambda x minus t. That means the formula it can be written x minus t into plus 1 resultant kernel. Next problem is kx comma t plus cos x plus 2 cos t. So k2 x comma equals to xt equals to k1 x comma t. So x k1 x comma z k z comma t into dz. So it can be written t x 2 plus a cos x divided by 2 plus cos z into 2 plus cos z, plus divided by 2 plus cos t dz equals to integration tx into 2 plus cos x divided by 2 plus cos t into dz, so x minus t. Next is k3 x comma t, k3 x comma t t2x x comma t x comma t kxz into k2 into k2 z comma t into tz equals to 2 plus cos x divided by 2 plus cos t into x minus t whole square divided by 2 factorial. So friends, we can write this way: kn x comma t equals to 2 plus cos x divided by 2 plus cos t into x minus t whole to the power n minus 1 divided by n minus 1 factorial. So rx t lambda equals to summation into lambda to the power n minus 1 kn x t equals to 2 plus cos x divided by 2 plus cos t into e to the power lambda x minus t. So I kernel. Now this problem is very interesting problem. The forward differential operator is defined as del un equals to un plus 1 minus un. Then which of the following difference equation has an unbounded general solution? So friends, I have to check each problem first problem, for first problem, that del square un plus, sorry, not plus, minus 3 del un plus 2 un equals to 0. So that is un plus 2 minus 2 into un plus 1 plus un minus 3 into un plus 1 minus un plus 2 un equals to 0. That implies this un plus 2 minus 5 un plus 1 plus 6 un equals to 0. Obviously, after calculation, so write this way: m square plus minus 5m plus 6 equals to 0. So I get the value m is equal to 3 and m equals to 2. So this type of problem is Z transformation. So we get C12 to the power n plus C23 to the power n. This solution is bounded. Sorry, not bounded, unbounded. First option is my correct option. Now we check as a multiple choice question. So del square un plus del un plus 1 by 4. So I can write un plus 2 minus 2 un plus 1 plus un plus un plus 1 minus un plus 1 by 4 un equals to 0. So it can be written this way, that un plus 2 minus un plus 1 plus 1 by 4 un equals to 0. So m squared minus m plus 1 by 4 equals to 0. So m equals to half, comma half. So repeated. So we can write this way: un equals to c1 plus c2n 1 by 2 whole to the power n. Now after that we discuss number 3, del square un minus 2 half to the power n as n tends to infinity, 1 by 2 whole to the power n equals to 0. No doubt it is bounded. un plus del un plus 2 un equals to 0. So un plus 2 minus 2 into un plus 1 plus un minus 2 into un plus 1 minus un plus 2 un equals to 0. So it can be written this way: un plus 2 minus 4un plus 1 plus 5un equals to 0. So it can be written e squared minus 4e plus 5 equals to 0. So m equals to, I can write, so m square plus 4m, sorry, this way, m square minus 4m plus 5 equals to 0. So I can write m equals to 2 plus minus I. Now the will be un equals to r to the power n cos over 5 to the power n cos theta. This is, I can write, this is c1 can be written c1 plus c2 root over 5 whole to the power n sine theta. So this is also unbounded. Number 4, del square un plus 1 minus 1 by 3 del square un equals to 0. So un plus 3 minus 2 un plus 2 plus un plus 1 minus 1 by 3. So my third option is also correct. Number, as a multiple choice question, so we need to check everything. 1 by 3 un plus minus 2 un plus 1 plus un equals to 0. And we retain 3e cube minus 7e square plus 5e minus 1 un equals to 0. So m, it can be written 3m cube minus 7m square into un equals to 0. M minus 1, 3m square minus 4m plus 1 equals to 0. So m equals to 1, 1 by 3, 1. So my problem will become un equals to c1 plus c2n plus c3 1 by 3 whole to the power n, that is unbounded. So friends, my fourth is also unbounded. Now next try to solve another problem. Question number 8.